Okay guys, in today's lecture we are taking a look at something called proportions. Proportions are a great tool when we are looking at conversions. We'll actually look at proportions a little bit later, and I can show you how some people even use them to perform dosage calculations when we will look at that a little bit later in the class. But what we want to look at with proportions today, I want to explain what a proportion is, and then I want to show you how we can utilize them in a number of different ways. So first, let me introduce you guys to what a proportion is. Some of you guys may be familiar with fractions. You may be familiar with something called ratios as well. What a proportion is, by definition, it is simply just two ratios or two fractions, which are actually the same thing, set equal to one another. What does that mean? So if you are familiar with, I didn't mean to do that. Let's undo that, sorry. So if you're familiar with fractions, like for instance, the fraction 3/4 just means 3 out of 4 or something. 3/4 written as a ratio can be written this way. We'll actually look more at converting ratios and fractions a little bit more next class, that they're actually the same thing. They're just written a little bit differently. The fraction that we have on top, 3/4, that is a fraction. Which is actually the same thing as the ratio that we have on the bottom. As you can see, just the same two numbers separated by a colon instead of a line. That is called a ratio, and it's read 3/4. If I take, and so again, these are actually the exact same thing, but a proportion is when you take either that fraction and set it equal to another fraction, or again, like we have on the bottom, I'm showing you guys that this is either or, that a proportion is either this, but actually that can be written as what's on the bottom, 3/4 set equal to 6/8. That this is also a proportion. Sometimes it's written as fractions and sometimes they are written as ratios. Both of the things that we have on the screen here are called proportions. Now, the only reason why these two are proportions is because they are two sets of equivalent fractions or equivalent ratios, that the two ratios set equal to one another are the same. And let me show you what I mean by that. So again, you can write it either way. Sometimes you'll see it written as a fraction, sometimes you'll see them written as ratios. They are interchangeable, they are one and the same. That the fraction 3/4 is the same thing as the ratio 3/4, and the fraction 6/8 is the same thing as the ratio 6/8. So you could see them either way. But again, a proportion if the two fractions are equal to one another, or again, ratios. I typically tend to write them as fractions. It's a little bit easier for me to see, as this is just kind of the way that I'm used to seeing them. So you might see them either way, but this is how I typically tend to rewrite them. So as we go through the rest of the lecture, you'll probably see me just write them as fractions. But again, we know that this is a proportion because these two fractions are equal to one another. Well, how do I know that these two fractions are equal to one another? Well, let me give you a scenario here. What I'm looking at on the first side of the equal sign, that 3/4, what this represents is, let's say I have a pizza and I cut it into 4 slices. If I ate 3 out of the 4, this is what that would look like. On the other side, let's say I took a pizza and instead I cut it into 8 slices. If I had 6 out of the 8 slices, 4, 5, 6, this is what it looks like. The reason why these are equal to one another, let's take a look at the area of the pizza that's being represented. Look at that, surrounded in green. Let's do the same thing to this pizza, surrounded in green. Does it still represent the same amount of pizza? Absolutely. These are what's called equivalent fractions. That means that they both represent the same amount, that 3 out of 4 slices of the same pizza that's cut into, if I cut that and looked at it as 6 out of 8 slices of the same size pizza, they're the same amount of pizza being represented. So that's just giving you a visual example, but am I going to have to draw pizzas every single time to determine if this is a proportion? Absolutely not. What we can look at here, an easier way to determine whether or not are proportions or not, again, they have to be equal. Let me show you an easier way to look at that. what we can do with this proportion here to test to see if this actually is a proportion, what you can do is you can cross multiply opposite sides of the proportion, meaning the top number of one side multiplying it by the bottom number of the other side. And it doesn't matter what side you multiply first. I can multiply 6 times 4 first or 3 times 8 first. Does not matter. The idea is to get the same answer. And you can probably see here that that's what's going to happen. If I multiply 6 times 4, I get 24. If I multiply 3 times 8, I get 24. As long as those two problems produce the same answer, it's a proportion. So the very first thing you guys are going to see in this section is simply just determining whether or not your proportion is true. Sometimes you might be asked, I think on the homework and on the quizzes it asks either true or false or yes or no. I take either one, it doesn't matter. But we're just determining if it is a true proportion. And this shows you that this one is a true proportion. Because that's what a proportion shows, is it's showing us that the relationship on the left is equal to the relationship on the right. So let's take another example. Let's say I have 2 to 5, or 2 is to 5, as, let's say 4 is to 12. For example. Now looking at this, you might be able to tell the relationship there, but you might not. Let's see. If we just simply cross multiply, again opposite sides, doesn't matter what side you multiply first. I'm going to multiply this side first just to show that it doesn't matter. 2 times 12 I know is 24. On the other side, 5 times 4 is only 20. So since these are not the same answer, this is not a proportion. So the answer to this would simply just be no. So that's what I'm looking for. Again, a proportion is showing us the relationship is equivalent on either side. And that's typically how a proportion is read out loud. If I said 1 is to 2 as 4 is to 8, then I want to know if that's a true statement. That's what it's telling us, that the relationship over here is equal to the relationship over there. Well, looking at this, you might be able to tell, well, yes, 1 is half of 2, and I know on the other side 4 is half of 8, so this has to be true. It has to be a proportion. And if you can look at it and just determine it that way without having to cross multiply, by all means, that is totally fine. If you can do it in your head, that's wonderful. But if we can't, that's what the cross multiplication method is there for. We simply just cross multiply. 4 times 2 is 8. On the other side, 1 times 8 is also 8. So yes, we get the same answer, therefore it is a proportion. And that's what a proportion is. And that's how we determine whether or not that's a true proportion. Now, let's draw that proportion up here now again. I want to draw that same one. I want to show you something that we can do with that same cross multiplication method. Now I'm going to take this exact same proportion and let's pretend that this 4 is not here. Let's call that x. We're going to call it x because it's going to represent an unknown. Proportions are helpful when we have an unknown value, meaning I don't know what number is supposed to be right here in this proportion. I can use this proportion to show that the relationship over here is equal to the relationship over here, so therefore I should be able to figure out what this value is. Now again, you guys just watch me erase that number 4, so you know that that answer should be 4. And also, you guys might be able to do it in your head and see that I know that 1 is half of 2, so therefore whatever this is half of 8. Okay, that's 4. But let's say it's not as simple as that. I want to show you, I'm going to start with this simple one so I can show you on ones that aren't as easy how you can use that cross multiplication method to find this number. So, bear with me for a second as I'm going to show you why these steps work and why the cross multiplication method works. And then I'm going to show you a shortcut and an easier way to solve this every single time. But here's what happens. Essentially what happens is when I'm multiplying 2 times x, since I technically don't know what x is, I can't multiply it. It doesn't have any value. It's an unknown number. So I'm just going to call that 2x to represent 2 times x. Just as we've done before, I'll set that answer equal to the answer on the other side. So cross multiplying 1 times 8 is 8. So now I have this kind of pre-algebra type problem that says that 2 times x, or 2 times something, some number, is equal to 8. Well, I know that 2 times 4 is equal to 8, but again, we're trying to see how we would figure this out if it wasn't one that we could do in our head. So what happens when you have a problem like this, where you're trying to solve for x, or you're trying to solve for an unknown? What you can do is you can get rid of everything that's on the same side of the x, so that at the very end, your statement then says x is equal to your answer. Right now it says 2 times x is equal to a number, an answer. So we want to get rid of that 2. So what we have to do when you're trying to do that, when you're trying to get x by itself on one side of that equal sign, what you have to do is you have to do the opposite of what's being done, and that kind of cancels out that number. So right now, since 2 is currently being multiplied by x, we're going to divide by that 2. And what that will do is it will cancel out the 2's and leave me with the x that I want right there on the left. But think about what this equal sign means. It means that whatever we do on one side, whatever's on one side is equal to the side on the other. So if we do something to the left, we should do the same thing to the right to keep it equal. So since I divided by 2 on the left, I need to also divide by 2 on the right. And that leaves me with the division problem, 8 divided by 2, which is 4. Now, let me show you that shortcut. Notice that what we ended up doing to get the answer to that problem, I took the answer to this multiplication problem, the 8 times 1, the multiplication of the side that's opposite of our x, and then we divided by the last number. That will work every single time, no matter where x is in your proportion. You simply just cross multiply the opposite side and then divide by the last number. So let me show you that same problem, but let's pretend now a different number is missing. So let's instead say that we have 1 is to 2 as 4 is to x. Again, because we're working with the same proportion, we know that the answer here should be 8. But let's look at it using that shortcut method. The shortcut method says that I can multiply opposite of where x is. So 4 times 2 gives me 8. Then I'm just going to take that answer and divide by the last number, which is 1. 8 divided by 1, my answer is 8. That's what I'm looking for here. And that will, like I said, work every single time. Let's look at one, maybe a completely different one. One that maybe we can do in our head to, again, show you that relationship. Let's say I have, how about 5 is to x, as how about 10 is to 30. Okay, so again, x is over on the left this time, no big deal. The right side, I know that relationship because I have these two numbers. I know 10 is to 30, but I want to know 5 is to what then? Well, 10 is actually a third of 30. So whatever it is that's over here, 5 must be a third of that number. So if you're thinking 15 in the back of your head, you're on the right track there. But let's find a way to use our cross multiplication method to figure that out. So again, we take the opposite side. So since x is here, I'm going to multiply the opposite side, take 5 times 30. 5 times 30 gives me 150. And then I'm going to take that number and I'm going to divide by our last number here, which is 10. Multiply, then divide. 150 divided by 10 is, in fact, 15. So that's what our answer would be. Like I said, this works every single time because you're showing I know this relationship. I know, this. If I set it equal to something else, there's my unknown, and I should be able to figure it out because of what I know about the other two numbers. Taking a look at another one. Let's say I have x is to 16 as maybe, how about, I don't know, I'm just trying to think of something that maybe isn't as easy to do in our head. 7 is to 9. Let's take a look at this one. So again, this one we might not be able to do in our head, but again, using our cross multiplication method. Opposite side says 16 times 7. 16 times 7 is 112. So I'm going to take that answer and then divide by our last number here. 112 divided by 9 is 12.4 repeating. If you ever got something like that, I would tell you just to round it to the 10th place. So it's just going to be 12.4. Okay. And again, if I don't tell you how to round, what's going to happen on tests and stuff like that? If I don't tell you to round, if you get an answer like that, I will accept 12.4, 12.44, however you round it. Just round that off, and that's totally fine. Okay, so everybody seeing what we're doing with these proportions? That we're just simply cross multiplying and then dividing, and that gives us our x. This cross multiplication method is really, really handy when we are trying to convert using maybe measurements. Anything that I don't know, I can use the relationship to what I do know, and it'll help me to solve for that conversion. Let me show you an example of maybe, again, one that I can do in my head. Let's say I'm asked this question. I'm given 3 hours, and I want to know what that is in minutes. I'm just using the abbreviations here just so I don't have to write out the whole unit. But, again, let's think about what I do know in hours as hours and minutes. And here, the question being asked is something I don't know. I don't know how many minutes are in 3 hours. But again, because I do know the relationship between hours and minutes, I can use that proportion method. What I could say here is I could say, well, 1 hour is 60 minutes, right? That's what we know about hours and minutes. What I don't know, and notice I put that on one side of the proportion because this is going to be what's called our known. Here's our known, what I do know about hours and minutes. What I don't know is this question again, the question up here that's being asked, which says 3 hours is how many minutes, or X amount of minutes. As long as your proportion is set up this way, as one side is your known, the other side is your unknown, and then actually what's going to end up happening in these questions, as long as your units match up, because remember a proportion is showing that we have a known relationship on one side, it's going to be equal to the relationship on the other side. So because I have hours and minutes set up as hours on top and minutes on the bottom of the known side, it should be hours on top and minutes on the bottom of the other side as well, to show that, again, what that equal sign means, that this is an equivalent relationship. But we solve it the same way we just did a second ago. Based on where that x is, I'm going to cross multiply. 60 times 3 is 180, and then divide that by 1 is 180 minutes. And that may have been one that you could do in your head. You may have looked at that and said, well, 1 hour is 60 minutes, so 2 hours would be double that, would be 120, and 3 hours would be triple that, so 180. Again, if you guys can do this in your head and you would rather just do those in your head, please, by all means, that is totally fine. The purpose of this is just to show you a method that you can use should you have any difficulty with that. All right, let's try another one. Okay. Let's see. Let's say we have, let's look at some more relationships that you might see in the nursing field, especially when dealing with perhaps maybe some medications. Let's say that doctor told a patient that they need to take 35 milliliters of medicine. Well, that might be better understood for parents or, for patients if we measure that in teaspoons. What I have given to you guys in your folder that you guys have for this class for this week, you guys will see a list of what's called your equivalents. These are the knowns that you can use in these questions. In that list, you guys will notice that you've been told that 1 teaspoon is approximately 5 milliliters. So therefore, that is your known relationship for your setup here. I know that 1 teaspoon is 5 milliliters. Again, this is my known. So I have to have that on one side of, you don't have to write the word known, but I'm just showing you one side of the equal sign should be those together, your 1 teaspoon and your 5 milliliters. The other side, so your unknown, is the entire question. Is the entire question that's being asked there. So the 35 milliliters and the X amount of teaspoons will now go on this side. However, remember we're showing an equivalent relationship. So on that known side, notice how I put teaspoons over milliliters. I need to have the same thing on the unknown side then. I need to make sure I have teaspoons over milliliters. Well, my teaspoons up here is my X. So that's why X amount of teaspoons will go on top and my 35 milliliters will go on the bottom. Oops, I started to write milliliters and I already had that down. Okay, my 35 milliliters goes on the bottom. And then, so now when I go to solve this, I can see that when I cross multiply 1 times 35, I cross multiply that side first since x is over here. 1 times 35 is 35, but then taking that and dividing by our last number gives us 7. So 35 milliliters is the same thing as 7 teaspoons. And that might make more sense to the parents that are taking this medicine at home. So again, the idea, the rules for these proportions, when you're using these as, solving these measurements, these equivalents, the rule for that is simply this, that when you're setting up these proportions on your own, rule number 1 is that you want to make sure you have your known on one side, your unknown on the other. It actually does not matter which side, if it's on the left or the right, as long as you have them set equal to one another. On that previous problem, if I wrote down my question first, if I said, 35 milliliters over X amount of teaspoons, that would have been totally fine. As long as, again, because my unknown is together, that whole question is the unknown. I'm just going to write UK for unknown. Well, the other side is going to be my K, my known. Well, again, because I need to match up units, that's where rule number 2 comes in. As long as your units match up, meaning that whatever you have on the top of one side is also the top on the other side, and whatever's on the bottom of your first side is also the bottom on the other side, those units. So on my known side for that question, I would have had to make sure that milliliters for my known are on top and my teaspoons are on the bottom. Well, my known again said 1 teaspoon is 5 milliliters. So my known would look like this then, because I want my milliliters to be on top. Let's see what happens when I cross multiply this problem now. As long as I followed rule number 1 and rule number 2. Rule number 1 says known on one side, check, unknown on the other, meaning I did not separate the 5 and the 1. It's on one side of the fraction, or the one fraction on one side of my proportion. The unknown, meaning the two parts of the question, the 35 and the X, are also on the other side. Do my units match up? Absolutely. I have milliliters on top of both sides and teaspoons on the bottom of both sides. Because of that, as long as I do that, I'm going to get this answer right. Since X is here, I cross multiply 1 times 35. Again, I'll take that and divide by 5. 35 divided by 5 is 7. And that's what we got on that problem. There's actually, as long as you follow these two rules, there's technically 4 correct ways that you could set up this problem. Because we could have had milliliters on the top or teaspoons on the top. You could have had your known on the left or the known on the right. As long as that's the case, as long as, however you set that up, as long as your known is together, meaning my 5 and my 1 had to be together because that was from that list. That's what I know to be true about milliliters and teaspoons. My question, the 35 and the X, that's what I mean by that. They have to be on the same side of the proportion. And then my units had to match up. Again, as long as you follow those 2 rules, when you're setting up those proportions yourself, you'll get the answer right every time. Let's take a look at a couple more and we'll practice with that. So let's say I have, how about 5 ounces, and I want to know what that is in milliliters. Sometimes if it helps, because the question is right there in front of you, you may want to go ahead and write that down first as one side of your proportion. 5 ounces over X amount of milliliters. Even before you look at that sheet to tell you what my known is for ounces to milliliters, because what that does is it now tells you that ounces are going to need to be on the top and milliliters are going to be on the bottom based on how I wrote down my question, my unknown. Remember, this is the unknown because it comes from the question being asked. Your known comes from that sheet that I've provided for you guys. If you look at that sheet, it shows that your relationship for ounces to milliliters shows that 1 ounce is 30 milliliters. And I just simply had to fill that in because I knew that I wanted ounces on top and milliliters on the bottom, just based on how I set up that question. So now when I go to solve this, since I've set it up correctly, my unknown was one side, my known is on the other, and my units match up, so we're good. So to solve this, I will cross multiply. Opposite of where X is, 30 times 5. Looks like 30 times 5, we know is 150. Divided by 1 is 150. And again, you might be able to do that in your head. You know that your list shows you that 1 ounce is equal to 30 milliliters. So 2 ounces would be double that. 3 ounces would be triple that. 5 ounces would be 5 times that. So you may have looked at that and just said, well, 5 times 30 is 150. And that is totally fine too. Again, the proportion method is just here to help you set that up. Okay, looking at another one. Let's say we have the exact opposite of that problem I just wrote down there. Instead of that question just now was ounces to milliliters. What if we had milliliters to ounces? As long as we follow those rules, we're okay. Let's say I have, how about 450 milliliters, and I want to know what that is in ounces. Again, if it helps, because there's the question right there in front of you, you can go ahead and write that down as one side of your proportion, because then that guarantees that you have your unknown on one side. You know that your known is going to be on the other. When you put that known on the other, this time I have milliliters on top and ounces on the bottom. So when I go to fill that in, I'm going to want to make sure I do that correctly. So I remember on my chart it shows me that 1 ounce is equal to 30 milliliters. So when I go to fill that in, I'm going to make sure that they're in the right spot. So because I need ounces to be on top, my ounces to be on the bottom, my 1 ounce goes on the bottom. My 30 milliliters goes on the top, if that helps to see that. So now I've got that set up correctly. I'm going to take 450 times 1, which is 450. 450 then divided by 30 is 15. So 450 milliliters is 15 ounces. And you can use that every single time. Use that proportion method to solve for those unknowns anytime. And like I said, if you can do it in your head, that's totally fine. You'll see in the review section I have another video that's titled Size Method, which shows that you can actually do this without using the proportion method if that's what you feel comfortable doing, where it shows that anytime I'm going from the smaller unit to the larger unit, based on that known that I had written down there, 1 ounce is equal to 30 milliliters. Ounces are obviously a lot larger than the milliliters, since 30 milliliters can fit into that 1 ounce, is a way to think about it. An ounce, think about an ounce is like the size of a medicine cup. Well, that medicine cup holds 30 milliliters. So milliliters are my smaller unit in this case. So the size method says that anytime you're going from the smaller unit to the larger unit, you would end up dividing by the known. And that's what we did in that problem. We took 450 and we divided it by 30. And that gave us our answer of 15. So some people who are trying to do it a lot faster use the size method. The proportion method, I think, is helpful for those who want to have some type of setup. But if you want to try it either way, if you want to try it in your head first, sometimes that works, where you can use the size method. Smaller to larger means we divide. If I'm going from the larger unit to the smaller unit, I'll always end up multiplying. And so on that previous one, when I was going from ounces to milliliters, you may have remembered that we multiplied by the 30. Let's try another one. Okay, so this way maybe you can look at it and maybe think about it either way. Okay, let's say I have 4.5 cups, and I want to know what that is in ounces. In this case, ounces are actually my smaller unit, because if you look at the equivalent sheet for this, my known says that 1 cup is 8 ounces. So ounces must be pretty small if 8 of them fit into that 1 cup. So in this case, I have 4.5 of those cups, so therefore I'm going to have 4.5 times the size of ounce, or the amount of ounces. So some of you guys may have looked at that and said, well, that's 4.5 times 8 then. Or if you're trying that size method, since cups are my bigger unit and I'm going to the smaller unit of ounces, larger to smaller will always end up multiplying by the known. So 4.5 times 8. But again, if you would rather see the setup, that's what the proportion is there for. That you can simply take your unknown, 4.5 cups and X amount of ounces, and set that equal to 1 cup over 8 ounces. And now I've got that set up correctly as unknown on one side, known on the other. And I've got my units matched up, so therefore I can go ahead and cross multiply 4.5 times 8, and then I'll divide by 1. So no matter what, I'm taking 4.5 times 8 to give me 36 ounces. Okay? And guys, that's your proportion. Proportions work in a number of different methods. We will actually use proportions. I'll show you how we can use those with dosage calculations a little bit later. Proportions are great even when we are using, when we have word problems. The great thing about word problems is you don't have to search for a known in an equivalence list like we had to do on those questions. A lot of times your word problems, when you're given those, you're given the known. What I mean by that, if I had a question that said something like, I'm not going to write all of this out, but Sally was eating a bag of chips. She read that the serving size, so I'm just going to put serving size, said that for every 10 chips, there are, let's say, for every 10 chips, there are 150 calories. Sally ate 17 chips. Oops. How many calories did she consume then? So see what I mean? In word problems, obviously I would have more wording to that, but I didn't want to write all that out. Sometimes word problems give us the known and tell us, well, here's what I know about these chips. The fact that there are 150 calories in 10 chips, there's my known right off the bat. 10 chips is 150 calories. Well, I don't know if Sally had 17 chips, I don't know how many calories she consumed. So same idea with that setup is that here's my known for the chips. I put my unknown on the other side, which is the question being asked. And again, I have my units matched up here. So chips on top, calories on the bottom. As long as I have those two rules followed, I will get this question right. X is here. So I'm going to go ahead and cross multiply the other side first, 150 times 17, which gives me 2,550, and I'm going to divide that by 10 to get 255. So Sally consumed 255 calories with those chips. So just kind of a thought there that sometimes word problems do the same thing, but the great thing about word problems is word problems will tell us the known somewhere in that problem, but then the question being asked is the unknown. So even if it breaks up the question itself, like if I said something like, Mr. Todd needs 200 milligrams of medicine. His medicine is 100 milligrams per every 5 milliliters. How many milliliters does he need to take? So how many, I'm just going to put how milliliters. How many milliliters does Mr. Todd need to take then? So the known in this question is actually in the middle of the question. So we know, what he needs. He needs 200 milligrams. But here's what we know about this medicine, that there's 100 milligrams for every 5 milliliters of that liquid. So anybody taking that, and we know from our equivalence list that that's about the size of a teaspoon. So for every teaspoon of this liquid that any patient takes would get this much medication, the 100 milligrams. Well, Mr. Todd needs double that. So you might be in the back of your head thinking, okay, well then he needs double the amount of milliliters. But let's use our proportions to figure that out. Okay, well we know that that medicine is 100 milligrams per every 5 milliliters. Mr. Todd needs 200 milligrams. How many? I use a question mark, but X is also fine there. How many milliliters would that be? So since my X is that same thing as that question mark there, I'm going to cross multiply 200 times 5, which is 1,000. Right? And then 1,000 divided by 100 gives us 10. So that would be 10 milliliters is what Mr. Todd needs to take. So that's why proportions can be very helpful. You just look at it as if I know a relationship between two numbers, I can use that known relationship to help me determine an unknown relationship that I don't know. So the most common thing that you guys will see, especially as nursing students, you will oftentimes need to utilize the proportions for those types of conversions. So those conversions are really going to be helpful. Because this is an online class, I don't expect you guys to memorize that equivalence list right off the bat, but I do think it would be to your benefit. As you guys get into your NPN classes a little bit further down the line, you might be asked some questions about the teaspoons and milliliters and the ounces to milliliters and the cups to ounces. Those are really important to know, as you sometimes may have to determine if I said that Mr. Johnson had 3 cups of coffee today, how many milliliters did he just intake? It's important to know that relationship for cups and milliliters for that reason. So things of that nature. That's why it's important for the nurses to get to know that equivalence list. So be sure to be familiar with that equivalence list. I will tell you that equivalence list is an equivalence list of approximate equivalence. Let me show you this is actually the list that I'm referring to. I have this posted for you guys. I've actually referenced a couple of these today, as we talked about in our lecture. We mentioned the teaspoon to milliliters. We did a cup to ounces. We did a ounces to milliliters. So these are actually some common ones that I would definitely be familiar with. As I mentioned previously, that you can have this in front of you, and that will help you with these questions. But I definitely would be sure to reference this and practice with it, as these are some things that will come up pretty often as you guys get further into your nursing program. And as I just mentioned too, that they are approximate equivalents, meaning that they are not exact. That if you looked up on Google how many milliliters are in 1 teaspoon, I think it's like 4.97 something. So 5 is rounded. It's close enough. And that's what you guys will need as you guys continue through your nursing program. But I say that mainly because looking up your answers on Google will be bad for you. Because if I asked you the question, for instance, if I said, if I gave you the question just using that as an example, if I said, okay, well, I have 4 teaspoons, what is that in milliliters? Well, it's because 1 teaspoon is approximately 5 milliliters. I'm looking for 4 times 5, which would be 20 milliliters. If you looked up on Google, and I'm just going to test, right now, just while I'm on my phone here, 4 teaspoons to milliliters in Google is 19.716 milliliters. If you give me this answer, you are incorrect. Even though that is exactly the right answer, I'm looking for you to do the math. I want to see this approximate answer. So make sure you're using the list that I have provided for you guys. Again, guys, this list is something that you will eventually want to memorize, as you guys will see this list often in your nursing program too. So even though right now in an online class you might be able to have it in front of you, you might not in, say, NPN 100. So just keep that in mind as you guys are going through these problems and you're going through and practicing. So just a little heads up for you. All right, guys, if you have any questions, let me know.